वहाँ पे बैकग्राउंड म्यूजिक में जाओ, कुछ भी लगा दे। यू कैन टॉक ब्रो।
हाँ करो भाई, म्यूजिक ही लगा रहा हूँ।
एक सेकंड, लेट मी सी इफ इट इज ऑडिबल ऑन यूट्यूब, जो हम अभी बात किए।
A very warm welcome from CodeChef KLSGIT. We are thrilled to have you all join for this exciting workshop. I am Aditya Singh, your host for today, and I will walk you through the introduction of our club and the introduction of our members and our esteemed guest. Starting with the introduction of our club, our journey started when a small group of passionate students decided to bring together like minded individuals with love for coding and technology. So, our primary goal of our club is to foster the coding community at GIT, where you can learn from one another and challenge ourselves and stay on top of the rapidly evolving tech landscape. So currently, our club is being led by Sarvesh Patil. He is the president of the club, and the vice president, Gauri Khoda. Our very first event, Idea Garage, an open house hackathon workshop, it was conducted on 19th November, and it was aimed at sparking creativity and boosting hackathon skills. And fast forward to today, and here we are hosting our exciting machine learning workshop. And we believe that having a foundational knowledge of ML can open doors to countless opportunities. This workshop is designed to provide a basic understanding of machine learning, the tools used, and how to build and apply for internships in this field. In today's workshop, apart from all the talks, we also have some quizzes and some exciting games for you guys. So we look forward to for your active participation. And thank you everyone for joining. And we hope you enjoy the workshop today. So it is time to call upon on the screen Sarvesh Patil, our first speaker. So
Hi,
hello
Aditya. It
Sarvesh.
was a nice introduction, and thanks for the introduction, Aditya. And yeah, that's all for me. Cool.
Yeah.
So let me take over from here. Thanks for the
Yeah.
introduction, Aditya.
Really happy. Yeah. Really happy for you to be here. And um, आप हमें बता सकते हो कि आज आप क्या करने वाले हो? What will this workshop be
So it's a
about?
basic ML workshop. जो आज का workshop है वो 2 घंटे का workshop है. There are three speakers. First speaker is me. Second speaker is Sneha, and our third speaker is our esteemed guest, Sukanya. So we will be guiding you with a proper roadmap for targeting ML as a career. The thing is, बाकी चीज़ों में development easily हो जाता है, and even the resources are very easy to hunt down. YouTube पे you can easily get how to do web development, how to do app development, or any sort of development that you want to do. But the thing is with ML, that students को it becomes very difficult to start their journey from, like, many people get confused कि कहाँ से शुरू करें पढ़ना, and they don't start their journey at all. So we are here to simply guide you, give you the starting ignition point, to take you to that ignition point and beyond, so that you can start your ML journey. So the workshop is in such a way that I will be teaching you very basics of ML कि कहाँ से शुरू कर सकते हो पढ़ना. The thing is, ML is so vast that you 2 घंटे में cover नहीं होगा, but we will be giving you roadmaps and the points where you can start your exploration from. So I will be giving you that part,
Yeah.
and Sneha will be teaching you about algorithms, machine learning algorithms. I will be teaching you basics of machine learning. She'll be teaching you algorithms, and our guest will be teaching you how to use those two skills to get an internship.
Yes. So आपका motive actually बहुत अच्छा है, and I wish you all the best for the talks, and I will leave you
Sure.
to it,
Thanks,
man.
Aditya. That was a great introduction. So, hello, folks. Myself, Sarvesh. I'm currently in fifth semester. हमारे SW अभी होने वाला है कुछ महीनों में. And that's all for me. And I'm here to teach you guys about machine learning. I've been learning machine learning since past a year. I'm currently a backend developer, and I'm trying to explore machine learning. तो अच्छा खासा 1 साल invest किया है हमने. And yep, that's for me. And let's get going. So, guys, if you can see my screen, what is machine learning? Field of study that gives computers the ability to learn without being explicitly programmed. So, whenever you're programming anything, we all know there are two ways to program. Two ways to program anything. एक होती है hard coding और एक होती है dynamic programming. हार्ड कोडिंग में जो हमारे फर्स्ट ईयर के जो फर्स्ट सेमेस्टर के लैब के कोड्स होते हैं, वेर यू हैव टू एक्सप्लिसिटली आस्क देम, put your value, put your enter the side of rectangle, enter the length of rectangle, whatever. That is called hard coding, and you yourself assign a value of 4 or 5. That is called hard coding. Dynamic programming ऐसी होती है कि you need not to dynamically put any values. You just have to code it once, and as per the situation, the code or the variables or data storage automatically manipulates itself. So this is something which is थोड़ा सा इसके ऊपर आता है, beyond, which comes in the part of algorithms, where you need not to PPT is not visible. Aditya, just a sec, guys. Please, can you message? Can you just can you guys see the PPT? Guys, the if you guys are there in the WhatsApp group, हमने जो WhatsApp group बनाया है, I guess the PPT is visible now. Okay, cool. The PPT is visible. I'm sorry, I'll start again. So nothing. No, not to rely on PPT. So yeah. So what ML is about, like जो आप dynamic programming करते हो, here you dynamically program some algorithms so that as per the situation they are designed for, they will work for you, and you need not to sit and watch them continuously. You just you just create them, and you just give them the resources whichever whatever that they are made for, and it works on itself. That is for machine learning. That is what machine learning is about and how it started. So the first machine learning model was a checkers game. The thing is, Arthur Samuel had created this checker game such that, and he observed, he just created it for fun. उसका उनका side project था वो. Obviously, if he had created some machine learning algorithm or project, he must be a PhD explorer, PhD scholar. So he had created this game, checkers game, to just check out how things work. एंड ही आफ्टर हिज ऑब्जर्वेशन ही सॉ दैट ये जो मशीन जो लर्न कर रही थी जिस स्पीड पे, द रेट ऑफ लर्निंग ऑफ दैट पर्टिकुलर गेम और दैट मशीन वाज वेरी एक्सपोनेंशियल. With a limited time space, it got to learn a lot of moves and new moves, and it could beat up a human into the game. It could beat the person in the game. So it could beat the person in the game. Uh, uh, Guys, can you guys what WhatsApp group mein, it's the permission, everyone has the permission to text in the WhatsApp group. Can everyone text if the PPT is visible? I've just sent a message in the WhatsApp group. Guys, please ping there if the PPT is visible. Cool. Chill out, guys. Just a second. Just a second. I'll be sharing my screen now. Yep. Okay. Let me share my screen. Okay. Is the PPT visible now? Can you guys see my screen? Okay. I guess the PPT is visible and we can go ahead. So, जब आर्थर सैमुअल ने गेम बनाया था ये वाला, द टाइम ही हैड क्रिएटेड द गेम, ही सॉ दैट द गेम वाज लर्निंग वे मोर एक्सपोनेंशियली. द rate of learning of that particular model was way faster than the rate of learning of those people. So then he realized that this could be a scope that we can teach machines. We can eventually teach machines, and machines can perform some machines can perform some way better than humans do. So this so learning about that, working from evolving from that stage to today, we are able to build machine learning algorithms in way better ways in much better ways, sorry. and these are the stages of machine learning model building. So जब आप machine learning model बनाने की कोशिश करते हो, there are these number of stages, and you have to go through each stage individually. So the first thing that you start with is problem definition. आप मॉडल किस चीज के लिए बना रहे हो? Like, if are you building it for are you building a chat model? Are you building a क्या कहेंगे उसको, weather broadcasting model, whether anything, you can, it can be related to anything, something like emotion. Most I have seen most of the people building emotion detector. So you have to first primarily define your problem definition. Then the second thing comes is data collection. Data collection is very important task in machine learning, because आप जिस डेटा के ऊपर मॉडल बनाते हो, उसके हिसाब से आपका डेटा कितना एक्यूरेट है, आपका डेटा कितना प्योर एंड क्लीन है, उसके हिसाब से आपका मॉडल वर्क करेगा. Sometimes what people do, it is that people focus more on algorithms, building the algorithm, rather than the data they are collecting. This creates a problem that unka model is very accurate, uska accuracy and precision is very high, but it is working on a very bad data set. So data collection is very bad, so it is performing poorly. That is the problem which people face, students usually face. Ki, I have seen in multiple hackathons, people, the judges ask them ki tumne kitna accuracy badhaya iska. They are not able to answer that, but sometimes they can only do is that they can train it on various data sets. Like Kaggle पे आप जब एक डेटा सेट डाउनलोड करते हो, you can download different types of data sets at the same time from different developers. और उसके ऊपर you can train it on 3 different data sets from different resources. That's my point. Different resources is very important, and that can also improve your precision of your model. So coming to the third point, that is pre-processing. Once your data is collected, most of the time we see that real world data is incomplete a lot. Real world data is incomplete. So what happens is, कभी कभी ये होता है कि people sometimes fill the form incomplete, or sometimes the problem happens in storing of the data, that some data gets eradicated, some data get erased. So that time you use pre-process, you first clean the data, that is pre-process the data. There what you can do is आप सारे null values हटा सकते हो, incomplete data remove कर सकते हो, और some irrelevant data can be also removed. Irrelevant data कुछ भी, sometimes people do is they add anything numbers की जगह, at the place of your phone number they put something in English, something gibberish values. You have to clean the data after the data collection step is done. Then the best part of ML, where we come to see that we have course projects included, electives, course electives. That is data visualization हमारा एक elective है. Why is that important? People don't know that. So the elective is important only because of this fourth part, that is exploratory data analysis. The thing is, you have collected a vast data, एक data जो millions में है, billions में है, और thousands में भी कह सकते हैं. The time it will take you to go through that data is a lot. So simply to understand the data without going through it is to visualize the data. And that's where tools like Tableau, Power BI, and our Microsoft Excel come simply. You use these tools to simply visualize the data, analyze the data. And this is also a job. Data analysis is a job, and usually data analysis people do this. That is, a huge collection of data comes to them, and they simply try to make sense out of the data, and they simply try to make that data easy, make it in some way that it is easy to understand to anyone, for a child. So that is the data analysis is done. Then feature engineering. I'll be covering about feature engineering in later parts of this workshop. Then with feature engineering, there is model selection. Model selection will be based on the problem definition that you have chosen. Sometimes you must be very much familiar to this, that आप अगर chat वाले model बना रहे हो, तो you will be working with LLMs, long chain models, or simply language models. If you're working with anything like right now, I'm not getting those ideas, but yeah, you guys have a clue about this. Model selection will be done as per your problem definition. Now model training. This is the part where ML engineers come into picture. Model training में what you do is you train the model. जो data हमने analyze किया था, analysis is only done for our understanding of the data. The data which was pre-processed, you will be using that for model training. Model training दो type के होते हैं. One is model training and one is testing. That is done. It will be covered by Sneha, I guess. So model training is done by ML engineers usually. Now we come to hyperparameter tuning. Once the model is trained, Once it is trained, समझो आपने train किया model को, the base accuracy you will get in the first go is always going to be a little less, somewhere around 60%. 60% to 70% आपका मॉडल रहेगा, उसका एक्यूरेसी रहेगा. सो देयर हाइपर ट्यूनिंग कम्स इनटू पिक्चर. Hyper parameter tuning, what you do is you try to change those parameters, if is it try to change the weights of those parameters and test आप उसकी एक्यूरेसी कैसे बढ़ा सकते हो. हाउ इज इट रिएक्टिंग व्हेन यू आर चेंजिंग दीज वैल्यूज. जस्ट प्ले विद द डेटा. दैट इज हाइपर पैरामीटर ट्यूनिंग. कूल, अंडरस्टूड. ओके, now we'll come to model evaluation. Once you have hyper tuned it, you will try to evaluate कि पहले मॉडल कैसे चल रहा था before I changed these things, and after changing these many things, these many parameters, how is the model working. That comes into model evaluation. Model deployment, these are the things which comes into again MLOps. MLOps is a field where you build machine learning models and you deploy machine learning models. That field comes under MLOps. Okay, we'll be teaching that in the further section. So let's move to the next section. So now machine learning algorithms. What is machine learning algorithms? Once you enter the field of machine learning, every first video that you watch on machine learning is going to be it will be these 4 points will be specified there. That is supervised learning, unsupervised learning, recommender systems, and reinforcement learning. These are the 4 parts, four main parts, the 4 subdivisions, 4 major subdivisions of machine learning. So as of now that you're a beginner, that you are a bachelor student majoring in bachelors, you will be studying mainly on you will be able to study supervised and unsupervised learning easily. So let's get into this, how it is. तो सुपरवाइज लर्निंग के अंदर 2 क्लासिफिकेशन है. अनसुपरवाइज लर्निंग के अंदर भी 2 क्लासिफिकेशन है. सेमी सुपरवाइज लर्निंग का मतलब रिकमेंडर सिस्टम, सेम थिंग. रिकमेंडर सिस्टम एंड सेमी सुपरवाइज लर्निंग मीन द सेम. Cool. Then comes reinforcement learning. Reinforcement learning is very difficult. That is usually the topics of research persons. The people who are doing research into machine learning will be usually dealing with reinforcement learning. Cool. So starting with our topic of the day, supervised learning. Supervised learning has 2 classification. Just a second, let me adjust my camera. Supervised learning has 2 classification: regression model and classification model. You guys can see that, right? Regression model on the left, right side pe classification model is there. Regression model ke andar we get logistic regression, linear regression, and decision tree. These are the very basic or very well known algorithms for regression. Then comes classification. Classification ke andar we have SVM, knife base, and k nearest learning, k nearest neighbor. Cool. If this is done, I'll be explaining you now about regression. Sorry, supervised learning. Let's come to supervised learning first. If you guys can see my screen right now, my slide, you guys will be able to see there is an X leading to Y, and there is an input leading to output label. The term supervised itself states that someone is being supervised. The learning process is being supervised by someone. That is, it could be anyone who is building the model. Supervised learning is very similar to teaching a child, a 3-month-old child, chota bacha, the way we learned, the way our parents taught us. It's very similar to that. How is that similar? So our learning cycle began with our parents showing us an image of an apple and telling that this is an apple. A for apple, this is an apple. Our parents taught us that way. And whenever an apple used to come, we used to point it out to that apple and say, that is an apple. This is how we learned. Most of us learned that way. Cool. This is very similar to that. We have an X, that is our input values. It is leading to Y. That is Y. It is leading to Y. That is output value. The thing is, we have a set of data which we know after calculation is going to produce some other set of data, some other set of values. Like 2 cross 2 is equal to 4. We know this statement. We tell our model that 4 is an answer when someone asks you 2 plus 2. Agreed? 4 is an answer when someone asks you 2 plus 2. This is the way how supervised learning works. We teach them the right answers for the right questions, and our model starts learning from there. These are supervised learning models. Let's come to the slide. Yup, here it is. Supervised learning models. The definition is a machine learning approach where models are trained on labeled dataset, predict outcomes for new unseen dataset. We first teach them the correct values, then they predict the later values, unseen values. The best part is, the worst part is that you have to collect the right answers, you have to collect the wrong answers, and you have to yourself segregate them and teach the model that these are the right answers, these are the correct answers. So you have to label the data. This part comes under data annotation, something called as data annotation, where you label every answer or every data which you have, every information, that this is a pronoun, I is a pronoun, he is a pronoun, sorry, I is not a pronoun, he is a pronoun, I is a noun. You have to segregate every piece of information and turn that information into data. That is data annotation, that is labeling of your data. Then is predictive modeling. It learns on predictive. You put your input and it gives you desired output. Simple. So the basic task is obviously image classification, spam detection. You teach the way spam detection works is that you teach your model that these types of messages are called as spams, and the model understands it and learns it. That if any message comes tomorrow to it, it will say like this is a spam, this is not a spam. Same as image classification. We as humans learned image classification that way. So what is this? This is linear regression model. This is, firstly, this is a regression model. Secondly, this is under regression, this is linear regression. What do you mean by linear regression? Most of you guys know what is linear regression, but it is hard to connect. The graphs which you have been drawing till your first year, second semester, physics chemistry cycle is what is just what linear regression is. आपने जितने भी straight line graphs बनाए अब तक, all of those graphs are nothing but linear regression models. How does that work? हम फिजिक्स क्लास में क्या करते हैं? स्क्रीन शेयरिंग, सो माय कर्सर विल बी विजिबल टू यू गाइस. कूल. हम फिजिक्स लैब में क्या करते थे? वी यूज्ड टू प्रेडिक्ट सम वैल्यूज, वी यूज्ड टू डू सम एक्सपेरिमेंट्स, एंड हम उसके आउटपुट्स देखते थे. एक्सपेरिमेंट नंबर नहीं, व्हाट डू यू, राउंड वन में ये वैल्यूज मिले, ये 3 वैल्यूज मिले. राउंड 2 में ये 3 वैल्यूज मिले. राउंड 3 में ये 3 वैल्यूज मिले. वी यूज्ड टू डू दिस. कूल. लेटर व्हाट वी यूज्ड टू डू, व्हाट वी यूज्ड टू ड्रॉ अ स्ट्रेट लाइन. फिर हम देखते थे वो क्रॉसेस हमने जो बनाए थे, डॉट्स हमने जो डाले थे ग्राफ में, वो उस लाइन के ऊपर कितने सारे रिलाई कर रहे हैं. इफ मेजर नंबर ऑफ डॉट्स आर ऑन टू दैट लाइन, इफ द लाइन, इफ मेजर नंबर ऑफ, इफ अगर सारे डॉट्स उस लाइन के ऊपर आ रहे हैं, देन योर आंसर इज करेक्ट. देयर इट इज पॉसिबल दैट देयर आर फ्यू डेटा पॉइंट्स व्हिच आर आउटसाइड द लाइन. इट इज पॉसिबल, आपको मार्क्स फुली मिलते थे. एग्रीड? That's what linear regression model is. It works mainly on one single line, one single equation, that is y is equal to mx plus c. Straight line equation. Cool. Cool. Then what is the next? This is the same. Now look at this. This is linear regression model. Cool. This is polynomial regression. Abhi kya hota hai? Whenever you're doing an experiment, you see that the graph which you have drawn, when you draw a straight line onto that graph, जब आप straight line बनाते हो उस ग्राफ पे, सारे डॉट्स जो आपने बनाए थे, they are not fitting on that line. Correct? In some experiments, आप जब डॉट्स बनाते हो और लाइन बनाते हो, सारे डॉट्स, all the dots will not be exactly coinciding with that one line. That's when your lab professor comes to you and asks you, don't draw this line, draw some other line. You just ऑप्टिमाइज योर रिग्रेशन मॉडल, सॉरी, ऑप्टिमाइज योर इक्वेशन. आप स्ट्रेट लाइन छोड़कर आप पैराबोला का इक्वेशन बना देते हो, सो दैट इट फिट्स ऑल द डेटा पॉइंट्स. एग्रीड? दिस इज पॉलिनोमियल रिग्रेशन. कूल. ये वाली लाइन जो है वो लीनियर रिग्रेशन की लाइन थी, दैट इज अ स्ट्रेट लाइन. दिस इज पॉलिनोमियल रिग्रेशन. आई विल बी कवरिंग दैट, नो वरीज. नाउ regression is done. Other type of what you call learning model is classification. How does classification work? Classification works in a very simple way. You know what is right, you know what is wrong. You are able to classify it, you are able to differentiate it. Correct? So whenever whenever regression comes into picture, we always have one specific example, that is housing price prediction. Cool. Now, whenever classification comes into picture, we always have one basic example, one starting example, that is cancer prediction, tumor prediction. How does that happen? We'll see that now. We have a graph over here. We have a graph over here, age versus tumor size. Cool. You guys can see that. There are some predictions being done. There are some previous predictions. There are some previous tests that has happened. They say that जिस जो इंसान इस एज के अंदर आता है, इस एज ग्रुप के अंदर आता है, उसको कैंसर नहीं है. And it could be anything. It could be a bruise. It could be anything. Simply, the person might have got hurt, and the cells are trying to regenerate, and it might appear like a tumor. My biology is very bad. I might be wrong here, but just imagine that way. Cool. So these circles are something. These circles consider these circles as not a cancer. Cool. मतलब ट्यूमर साइज अगर इस वाले साइज के अंदर आता है तो वो कैंसर नहीं है. बट अगर ट्यूमर साइज इसके बियॉन्ड आता है तो वो कैंसर है. दिस इज वेरी बेसिक अंडरस्टैंडिंग ऑफ ग्राफ. कूल. अभी इस ग्राफ के अंदर हम लीनियर रिग्रेशन मॉडल रन कर नहीं सकते. एग्रीड. व्हाट वी कैन रन इज अ क्लासिफिकेशन मॉडल. व्हाट वी डू इज वी write such equations. We write such equations so that equation is able to classify or divide the graph into regions, main two regions. We have learned this in M2. मैथ्स में हमने पढ़ा था, रीजन्स ड्रॉ करते हैं हम लोग. लाइक इफ वी ड्रॉ अ लाइन एंड इफ द वैल्यू इज ग्रेटर than the sum of the slope, greater than the slope, not slope, greater than the sum of the equation, it is beyond that line. If it is less than the sum of that equation, it is under that line. We have studied this in M2. Cool. That's what it is. We draw a line over here and we shade this part, and we say that these values comes beyond the summation of the equation of line. That's why these values can be tumorous. These values state that something is tumorous. Correct? Agreed? Understood. So now we'll be moving to the next part. That is, let's revise. Let's revise before we go to the next part. Supervised learning is the basic starting point where you have to start your ML journey. Supervised learning क्या होता है? It is simply learns from being given right answers. Cool. There are two types in supervised learning: regression models and classification models. Regression models, the best part. Now you might say, why is there a differentiation between these two things? I'll tell you. In life, in real world, not everything can be numerically quantified. Agreed. One cannot express their emotions in numbers. Agreed. You can only quantify physical things, but you cannot quantify something which is emotional, like not physical. We can say you cannot quantify your love. You cannot quantify your any emotion. Cool. Sticking to that statement, we see that there are two ways in which you can study. That is, you can study with numbers or you can study without numbers. Cool. Regression models runs only on numerical data sets. Regression models runs only on numerical data set. It is very easy for a regression model to run when some values have been assigned, some labels have been assigned to something. And classification models runs into categorizing things. It runs by categorizing things. Color. You cannot say how much red. You can only say that it is red. Cool. So color classification is there, shape classification is there. There are a lot of classification. These classifications, anything which is related to classifying things, works under classification models. Anything which has numerical values assigned to it, or any parameter which has numerical values into it, comes under regression model. Cool. Now we are done with supervised learning. We come to the second part, that is unsupervised learning. What do you understand by unsupervised learning? The term unsupervised. Unsupervised का मतलब है that learning is not being under observation of anyone. इसका मतलब क्या है? The data sets which you provide are not going to be labeled to the model. Cool. पहले क्या होता था? We had some outputs, we had some inputs. We were putting labels onto that this is correct, this is wrong, this is correct, this is wrong. यहाँ पे वो नहीं होता है. We are not putting labels on anything. the model has to predict by itself that this is right, this is wrong. How does that happen? So it generally works with grouping customers. Like there are some customers who pay this much amount. There are some customers who pay this much amount. पैसे जितना खर्च के ऊपर है उसके हिसाब से we can group them. Group the customer experience. We can group this. Sorry, not the expenditure करते हो तो regression लग सकता है. But customer experience you have to group it here. Grouping customers. Cool. What does this say? The type of learning model identifies patterns or clusters into data which are not labeled. Cool. Best example for this is k-means algorithms. I'll be teaching you that later. I guess Sneha will be covering that. Sorry. Cool. Works best with unlabeled data sets, includes clustering, dimensional reductions techniques. No explicit target variable. मतलब हम कोई बाहर से टारगेट नहीं रखते दैट दिस इज करेक्ट दिस इज रॉन्ग वी आर नॉट पुटिंग एनी टारगेट वेरिएबल कि what we do in if statement is that we put x is equal to, if x is equal to 1 we are not doing that here target variable नहीं है हमारे पास cool so let's get going with revision unsupervised learning data sets data only comes with inputs x but not with output y algorithm has to structure algorithm has to find structure algorithm has to find a pattern into the data we have provided what are the basic types of क्या कहते हैं इसको unsupervised learning clustering dimensional reduction and anomaly detection clustering is simply clustering हमने पहले देखा था एग्जांपल में देख लिया anomaly detection is email verification email validation spam detection dimensional reduction will be covering later इसमें क्या होता है dimensional reduction में हम डेटा को compress करते जाते हैं there is a huge number of data we are trying to compress it to learn it easily you cannot learn squares if I give you a target to learn squares till 100 you will not be able to learn it in a single go what you can do is simply आज मैं 20 तक squares पढ़ूंगा कल मैं 20 से 40 तक squares पढ़ूंगा you try to reduce the dimension then learn that's how this works now let's get the boat sailing and without machine learning you have to code everything into your algorithm or model with machine learning you have to only throw your data into it getting the point so that's a nice meme or nice template thanks for that let's get going with our first model first part of machine learning that is linear regression the most easiest part what you guys can see from the slide there is a training set there is a learning algorithm there is one equation function let's call function there is one function f there is an input value x and there is an output value y hat what do you mean by y hat this is very easy y hat का मतलब है you first predict something like there is an ideal situation for every equation right अगर आपको अगर आपको x value दी गई है ideally if everything is ideal you have to get value y that y value ideal y value is called as y hat cool so जब हम नॉर्मली कुछ भी इक्वेट करते हैं वी विल गेट y वैल्यू एंड जब आइडियली इक्वेट करते हैं लाइक गोइंग फॉलोइंग मैथमेटिक्स the value of y will be getting is y hat following reality chemistry or physics what value will be getting is y simple y so this is a simple linear regression model यहाँ पे क्या हो रहा है we have a price prediction we have a house size तो हम देखते हैं कि we are checking if the price of the house is correct or not so we say 750 square feet के घर का प्राइस ideally this is y hat value okay ideally we are supposed to get 150k but what are we getting we are getting 200k नुकसान हो गया फंस गए हम लोग गलत वैल्यू था इट्स अ स्कैम नॉट स्कैम whatever I'm sorry getting it this part is called error ये जो डिफरेंस आएगा यहाँ पे दिस क्रॉस को लेके और इस लाइन को लेके दैट इज कॉल्ड एन एरर कैलकुलेशन के अलग स्टेप्स होते हैं विल नॉट बी कवरिंग दैट दैट्स टू डीप फॉर यू राइट नाउ so let's I guess you guys have understood linear regression uh, mhm. Cool coming next Definition of linear regression: it's a supervised learning model where, see, it's a supervised learning algorithm used for predicting continuous dependent variables, dependent and independent, where x is dependent, x is independent, and y is dependent. So linear regression works on the very basic equation y is equal to mx plus c. यहाँ पे w, you will be able to see something called as w, w1, w2, w3, and b. That w1 is called as weight. Weight, I'll be covering it later. Don't worry, don't stress on this. Let's get ahead. Minimize square error. Sorry, mean square error. This is that the method to calculate the error between these two values. We have mean square error. Best fit find करने के लिए. Cool. Assume that linearity dependent and independent. Normal, very very normal. You guys already know this. So what is difference between linear regression and polynomial regression? Linear regression is what we call is something very basic, and whenever we hear this from someone, they know polynomial regression. It appears cool, but it's the same thing. Okay, it's the same thing, but it appears cool. That's why this beam. Chalo, you guys can have some fun time. Let's go to the next part, optimization. अभी हमने क्या किया? What we did is we did linear regression. If you are working with some, let's suppose we are building our own housing price prediction model. What we are doing, we are building our own house price prediction model. So what we did now, we understood what linear regression is. We analyzed our values. हमने x के लेबल को डिफाइन किया, that is houses size in feet, and y को हमने लेबल किया, that is pricing. Cool. We have done this. We have built our model, and we know the equation, the function of our model, that is y is equal to mx plus c. That much is done. Now that we have built a model, we will try to optimize that model. The optimization part comes कि ऐसा नहीं, अब ये error कम करना है हमको. So error कम कैसे करेंगे? For linear regression specifically, there is root mean squared error. But in general, for machine learning, what we have is called optimization techniques. There are different optimization techniques. One of the technique is root mean square. Another technique is gradient descent. This is also there in your term work in M1. अगर आपने MATLAB में अच्छे से फोकस किया था, MATLAB lab में, तो you must have designed such kind of a graph, plotted such kind of a graph, 3D graph. What is this? This is in general visualization of your data. How does this work? Let's get going with that. Before that, let's know what optimization is. Optimization is a process of finding the best possible fit. हम हमारे डेटा सेट को कैसे ऑप्टिमाइज कर, डेटा सेट को कैसे करेक्ट कर सकता है, हमारे मॉडल ट्रेनिंग को कैसे ऑप्टिमाइज कर सकते हैं, कैन बी डन हियर. दैट इज डन बाय एडजस्टिंग द पैरामीटर्स. नाउ adjusting the parameters. What are parameters? Parameters are nothing but the y-axis and x-axis, by adjusting the values of that. So to improve the model performance, we have to minimize the loss. अभी loss हमें optimize करने का reason क्यों है? Why do we need to optimize the model? First point and very important and necessary point is that optimization reduces our calculation. Calculation जब हमारा कम होता है तो GPU उस पे effort कम पड़ता है. So if you have to run a heavy, we all know that ML models are very heavy. If you have to run any model into our normal systems, जिसका गेमिंग लैपटॉप नहीं है, अगर वो ट्राई करेगा मॉडल रन कर रहा, तो दैट इज वेरी डिफिकल्ट. दैट इज नियरली इम्पॉसिबल. द लैपटॉप माइट गेट हैंग, आपका रैम खराब हो जाता है, मेमोरी खराब हो जाती है. सो व्हाट वी कैन डू, वी कैन ऑप्टिमाइज द मॉडल, optimize the math functions. How do we do that? We are simply doing our trial and error and trying to find out some best fit for our equations, mathematical equations, which will get us the right answers. Cool. अभी like learning from here. अभी देखो यहाँ पे, our first try was always whenever we get a graph, we draw a straight line. That is our first trial and error. If we go and we see that there are error coming here, इतने सारे data points हमारे correction पे नहीं है, इतने सारे data points are beyond our correction value. So what a smart person will do, he is like, मेरा model गलत नहीं है, मेरा equation गलत है. So what he'll do, he'll simply go back here. I need to go back few slides. He'll simply go back here and draw a polynomial equation. He'll not draw a linear equation, one single linear equation. He will not draw a linear equation. He will draw polynomial equation. And now we can see that this polynomial equation is also fitting these data sets. That is something called optimization as well. This can be also considered as optimization. Where is the slide? So, yep, optimization. You guys understood optimization. So we are simply fine tuning our model. We are simply doing trial and performing trial and error and trying to get to. We are trying to reach to some point. Cool. Let's go ahead. Coming to the specific point, what is that is gradient descent. Gradient descent is very general and very easy technique for optimizing any type of regression model. Why so? I'll be showing you now. अभी आप यहाँ पे देख रहे हो द रेड पॉइंट ओवर हियर द रेड टॉप हिल इज द एरर पॉइंट समझ रहे हो द रेड पॉइंट रेड मार्क यू कैन सिंपली विजुअलाइज इट एज माउंटेन्स जब आप पीक पे जाते हो वहां पे एरर वैल्यूज बहुत होते हैं and we have what we have to do we have to somehow bring the equations we have to somehow change the equation such that our calculations will go from here to the least point यहाँ पे जाना है हमको blue zone में जाना है we have to go from the red zone to the blue zone PUBG players might be knowing this free fire any dude I don't know games man sorry so आपको red zone से blue zone में जाना है ठीक है so what you have to do you have to optimize your equations one is the one thing is that you have to optimize the equation अब now being a bachelor being a engineering student who is poor in maths आप 2D ग्राफ तो कर लोगे बॉस यू विल ऑप्टिमाइज अ 2D ग्राफ इट इज इजी अब 3D ग्राफ कैसे ऑप्टिमाइज करोगे आप दैट बिकम्स डिफिकल्ट come to something which is beyond easy just something we come to heavier complex equations how do you think you are going to optimize those complex equations we are simply going to take simple steps we need not it is not necessary for us to reach from here to here in a single step what we can do we can take small steps we can do iterations that's why that is the reason why we do iterations we do iterations to arrive to the right answer most optimized answer how is that we jump from here. I'll be teaching you now. This is a 3D graph. This is a 3D graph. It is very difficult to calculate, do our calculations in a 3D graph. So what do? We simply ignore the third dimension. Ignore it. x1, x2, y1, x1, y1, z1. Z को 0 मान लो. Up you calculate x and y. Agreed. You calculate x and y. That is the most easiest way you can start optimizing your model. This is optimization model. This is called as gradient descent. This is an equation. This equation is iteration ka equation. You put this in a loop, in a while loop, and you try to iterate it. While loop में नहीं डालते. Sorry, it's a very क्या बोलते हैं? My basic go for anything is put it in a while loop. I'm sorry for that. You don't put this in a while loop. My bad. This is the equation. Theta is equal to alpha dot delta of delta नहीं बोलते यार इसको क्या बोलते हैं? I don't know. That is equation of क्या कहते हैं? This thing is the equation of slope, derivation of J. Cool. This is done for model optimization. Let's go. This is the equation WB. What did we do? हमने Z को 0 मान लिया. This was W, this was B. This was W, this was B. इसको हमने 0 मान लिया. We can see a 2D graph. Ignoring the 3D, but you can see a 2D graph. If you can visualize it. We'll be going there. This is the equation. This equation is, if you guys are familiar with 12th maths, you guys know that differentiation on any line of equation, any straight line on a graph will give you slope of that line, slope of that graph. Agreed? Slope of that point. Agreed? What are we doing? We are trying to move from here to here. How are we going to do that? We have to calculate the slope. Correct? To move from here to here, you have to first calculate the slope. So what are we doing here? We are calculating the slope. Differentiation. This will give you the slope. Cool. This is for value W. This is for value B. Let's get here. Let's get to the point. We have removed the third dimension. We have gotten a 2D graph. What are we going to do? We are going to calculate slope at any point. Cool. And that's the value of slope will define the number of iterations you need to take. Cool. Chalo. Here, what do we see? We put a point here. We are trying to calculate the slope over here. We calculate the slope and we get a positive slope. We get a positive slope. This slope is positive. Okay. This slope is positive. Whenever you get a positive slope, you have to make sure that you are iterating towards the left. Understood? बहुत simple बात है यार. If you have a positive slope, understand that your right side of the slope, your right side to the depth, you have to fall down here. If you have a negative slope, you are here. You have to fall down here. इतनी सी ही बात है. If you get a positive slope, make sure that you're iterating it to the leftwards. If you get a positive slope, you have to iterate it to the right. Simple thing. Agreed? Understood? I guess it is very easy. Let's go ahead. So that's all for our gradient descent. It was nothing, but it is nothing but optimizing the model. How do you optimize it? By reducing the rate of errors. Reducing the rate of errors, decreasing the errors. So how do you decrease it? Whenever you get a data set, you visualize it, you get to see that the values you have got are here. They are way far from optimized value. What you do, you simply ignore the third part, make it zero, make the third dimension zero. Done. Then what you do, अभी आपको किस तरफ जाना है? आपको इस तरफ जाना है, आपको इस तरफ जाना है, आपको उस पहाड़ के पीछे जाना है. आप वो कैसे डिसाइड करोगे? टू विच साइड यू आर, टू दैट स्लोप. अगर आप उस स्लोप के, आपका स्लोप अगर पॉजिटिव आया तो आपको जाना है लेफ्ट में. अगर आपका स्लोप नेगेटिव आया तो आपको जाना है राइट में. अंडरस्टूड? This much is very easy. The thing is, I'm not going to be explaining you math part of it because बहुत time लग जाएगा. I'm sorry. It is very difficult for us to explain math in online mode. We will be very happy to take an offline session as well, but that is for later part. So agreed. इतना समझ आया आपको? Optimization is also done. Now, once optimization is done, what we had learned in our first slide, that model training is done, hyper tuning is done. What you need to do now? You have to do the feature scaling part. What is feature scaling? What is feature scaling? Cool. Now, taking the example of house price prediction, we know, taking the example of house price prediction, we have to predict price of the house. What we have to predict? Price of the house. What are the parameters we have? We have size of the house, we have BHK, and we have age. Age का मतलब क्या? घर कितना पुराना है. आप जब भी घर देखोगे, आप घर रेंट के लिए देख रहे हो या खरीदने के लिए देख रहे हो, योर प्राइमरी ये रिक्वायरमेंट्स, योर प्राइमरी कंडीशंस विल बी, आपको इतना बड़ा घर चाहिए, स्क्वायर फीट में आएगा. आपको 3 बेडरूम का घर चाहिए, और फिर घर नया होना चाहिए, पुराना घर नहीं चाहिए, नया होना चाहिए, रिनोवेटेड होना चाहिए, कुछ भी. आप इन तीनों मेन पैरामीटर्स के हिसाब से, आप अपना कॉस्टिंग के हिसाब से, पैरामीटर्स के हिसाब से आप एक घर चूज करते हो. बट दैट टाइम यू हैव टू गेट टू नो, दैट टाइम यू हैव टू कैलकुलेट दैट वो जो बेचने वाला इंसान है, द ब्रोकर, क्या वो सही वैल्यू, सही दाम दे रहा है कि नहीं, या चूना लगा रहा है. हाउ आर वी गोना डू दैट? We are gonna do feature scaling. We are trying to teach our model to do this part. Is the price correct? Is the price accurate? या गलत price है? We are gonna do that. How are you gonna do that? The easiest way to build such model, to build a model which will predict price, is to do feature scaling on regression models. What is feature scaling? Now the best part comes. यहाँ पे जो आपको दिख रहा है ना, considering beta value, beta 0, beta 1, beta 2, that is weight of a value. मतलब एक नॉर्मल इंसान जब घर खरीदने जाता है, शायद से वो एडजस्ट कर लेगा. अगर घर बड़ा है और बेडरूम कम है, समझो घर, द हाउस एरिया इज 1200 बट बेडरूम्स आर 2, ही माइट मैनेज, ही विल बी लाइक चलेगा, कूल. इतना समझ आया? घर छोटा, अभी समवन माइट बी लाइक घर छोटा है, सॉरी उसको नया घर चाहिए, बट दीज टू थिंग्स, size and bedrooms, are satisfying conditions. These two conditions are being satisfied, and the house is very old. He'll be like, I'll adjust. घर बड़ा है, ये है, वो है, I'll adjust. What are these? These are weights. These are his desired requirements. How are these requirements going to happen? तो these are beta values. वो बंदे के हिसाब से ये values, बंदे के weight के हिसाब से ये values चलेंगे. How is this going to happen? Beta 1, beta 2, beta 3. हर चीज को दे दो. Now, if we consider a normal state, I have to go speed. Sorry, time up हो रहा है. I have to, considering a normal situation, if we calculate, if we equate this thing, what values are we going to get? The pricing part is beta 0, beta 1 into size, beta 2 into bedroom, beta 3 into age. अगर हम सिंपली वैल्यूज पुट करते हैं हमारे इक्वेशन में, the calculation, the round off of the house price is going to be beyond 60 lakhs. Is it valid? I don't know. And we are talking in dollars, okay? Please, we're talking in dollars. इंडिया में घर 60 लाख में आ सकता है, but dollars में नहीं. Cool. What do we do? We change what do we change? We scale. We change the features. Features matlab parameters. Features matlab house ke qualities. What are we going to do? We are trying to scale it now. How are we going to scale that? This is the formula. ये फॉर्मूला डालो, इस फॉर्मूला के हिसाब से इन वैल्यूज को चेंज करो और आपको ये वैल्यूज मिलेंगे. If we put this formula, if we put these values into this formula, we are getting these values. How are we gonna get these values? X is normal. आप जिस हाउस को देख रहे हो, आपके कॉस्टिंग में सबसे सस्ता हाउस कौन सा है? 900 का है, यहाँ पे 900 आएगा. मैक्स वैल्यू कितना है? 1500 आएगा मैक्स. एंड द डिफरेंस यू गेट एक्स. इसके हिसाब से एक्स डालो, इसके हिसाब से वाई डालो, इसके हिसाब से एच डालो. डू दिस. Once you have done that, now we are getting a proper appropriate value. Agreed? Then understood. This is called feature scaling. Now the last part, once you have built a model, is to validate that model. How are we going to validate that model? This is very crucial. This is very crucial. There is a smart person. There is a smart person. What that smart person does is फिजिक्स में उसको एक ग्राफ आया, उसको एक प्लॉट आया, प्लॉट आया, that he has to connect and he has to draw a line. A normal person, what he does is he draws a straight line. Everyone's basic reaction is going to be to draw a straight line. Second reaction, if he's a little bit smart, उसको थोड़ा सा मैथ्स आता है, he's good with mathematics, he's going to do is draw a polynomial graph. Like कोई भी graph so that it fits the data points. Now, a over smart person, a person who wants to be 100% accurate everywhere, what he'll do, he will simply make an equation in such a way that it fits all the data sets. यहाँ पे जितने भी पॉइंट्स है वो सभी हो रहे हैं. Now this is a simple straight line graph, straight line equation. What is this? This is polynomial equation. Now what is this, boss? This is very difficult. Why is this complex? Because there are ups and downs. इस ग्राफ का कोई सिंगल डायरेक्शन नहीं है. और डेटा वैल्यूज के हिसाब से यहाँ पे पॉइंट डालोगे तो इस पॉइंट को पॉसिबल बनाने के लिए, इस लाइन को पॉसिबल बनाने के लिए, these many values have to be considered. These many complexities, math complexities has to be considered. This is very difficult. What does this do? What does this give? एक normal human, for a normal human, this gives complexity on brain. A person who is decent with maths, he'll be able to calculate this. But for him to calculate this in an exam hall, it is very difficult. It takes a lot of time. Same thing goes with our models. If you are building a model which is too optimized, it is going to cost you a lot in terms of GPU. क्योंकि वो गलत पॉइंट्स को भी करेक्ट प्रूफ करने की कोशिश कर रहा है बॉस. वो गलत पॉइंट्स को भी करेक्ट प्रूफ करने की कोशिश कर रहा है. एग्री? दिस इट टर्न्स आउट टू बी रॉन्ग. Suppose this point is supposed to be out of the box. This is a wrong point which we have ticked. But this is a correct point. But यहाँ पे there is a chance of error and this can be considered into error. But what are we doing here? What is the model doing here? वो जानबूझ के इसको करेक्ट करने की कोशिश कर रहा है. So this is called as overfitting. Overfitting of any data points. This is called as underfitting. And this is underfit. Perfect. This is perfect. This can be considered perfect. It is not. It can be considered perfect. So here is the differentiation. Model is too complex. Overfitting में, underfitting में model is too simplistic. यहाँ पे आपका इक्वेशन बहुत सिंपल है, ये हर चीज पे काम नहीं आएगा. यहाँ पे आपका इक्वेशन बहुत ही ज्यादा डिफिकल्ट है भाई, बहुत ही ज्यादा डिफिकल्ट. ये काम आएगा, बट ये काम आने के लिए बहुत खर्चे जाएंगे बॉस. महंगा हो जाएगा. It will be very difficult for us to. It won't be cost effective. It won't be not effective in any terms because it is going to prove wrong things as right. Getting? तो एक एक्सट्रीम लेवल पे गलत हो जाएगा ये. सो यहाँ पे ट्रेनिंग फिट वैलिडेट्स द एरर. हाउ डू वी डिफाइन दिस? नाउ अभी एक एग्जांपल देता हूं मैं. आपको पता है करेक्ट आंसर क्या है, गलत आंसर क्या है? करेक्ट है. आपको पता है करेक्ट आंसर क्या है, गलत आंसर क्या है. ये करेक्ट आंसर करेक्ट बता सकता है. समटाइम्स व्हाट विल दिस विल डू, ये करेक्ट आंसर को रॉन्ग भी बता देगा. सेम थिंग विथ हियर, बट ये ज्यादातर आंसर रॉन्ग बता रहा है. ओके, दिस थिंग ओवरफिटिंग, अंडरफिटिंग, what it is doing is correct answers को भी sometimes it is saying that it is wrong. But yeah, most of the times it is so simple model, it is so simple equation that sometimes what it is doing, this is correct answer, इसको भी wrong proof कर रहा है. वो गलत हो गया. What is a good fit? करेक्ट आंसर है, करेक्ट आंसर है, गलत आंसर है, गलत आंसर है. एक्यूरेसी इज हाई. यहाँ पे एक्यूरेसी थोड़ा सा फकअप हो जाता है. नाउ ओवरफिटिंग, व्हाट इज दिस डूइंग बॉस? ट्रेन्ड ट्रूली ऑन virtual data sets. मैं खुद ही अभी मैं थोड़ा और ज्यादा चालू इंसान हूँ. What I'll do? I'll simply draw a math line equation, straight line equation, and I'll simply point point some values on that line, straight line, and I'll say I got the correct answer. मेरे सारे values prove correct हो रहे हैं. But experiment के हिसाब से वो prove नहीं होने चाहिए थे. That is called too much of accuracy. Real data, when we put real data into our data set, into our model, it is proving the correct values as wrong, which is wrong. Sorry, wrong values as correct, which is wrong. So this is it. This is overfitting, underfitting, and gooding. I have basically taught you very much basics from where you can start studying a ML model. Don't worry, don't stress. I know the time is less. We'll be sharing you, uh, we'll be sharing you some documents and some resources as well linked into that document, which you can refer later. This, क्या कहते हैं इसको? Later this workshop. Cool. I have covered all these major parts which are necessary for model building. Now, अब मैंने जितना बोला है आपको, what you can do, you can simply go on Kaggle, you can refer some code bases, and you will be able to understand what is happening in the code. That much we have done in this session. Cool. Let's go to the bottom. Let's go to the bottom. Come on. Overfitting is done. This is simple. Underfitting. देखो. This will explain you everything. This can be done. Can be considered. Middle wala. This can be considered. And this is too much only. How can you be so right, man? इतना बड़ा ग्रीन फ्लैग कोई नहीं होता, ठीक है? इतना बड़ा ग्रीन फ्लैग कोई नहीं होता. This is very risky. That person has to be pretending if he's too good. Everyone knows this. Model is too good. He's pretending, boss. Chalo. Now, I guess everyone ये last वाला part was must be easy for everyone. So now you guys can enjoy all the memes related to machine learning. That is machine learning, overfitting, underfitting, and underfitting. Thanks for this meme. The meme was given by my teammate, what's his name? Tanishk. So thanks, Tanishk. Thanks for these slides. And I guess I'm done. I'm done for the day. I hope my session was good. Now, I guess I'll be calling Aditya on screen. Aditya.
Yeah, hello once again. So thank you very much, Sarvesh, for this talk, and thank you, Tanish, for this meme. Very creative. And yeah, so we actually have a 5 minutes break, but in that break we have a quiz, right? So we'll be heading on to the quiz. We'll be sharing you a link, and that quiz will be on what Sarvesh has taught till now. So yeah, Sarvesh, you can rest now. I will take care of the audience now. I'll share the link on. If you are on YouTube, you can get it in the live stream chat, or if you're in the Google Meet, आपके chat में आ जाए. So I'm just waiting for participants right now. Is the link shared? So still no participants. Yeah, okay, there you go. I'll be starting the quiz after I get थोड़े तो लोग आने चाहिए. Right now I have 15 participants. Okay. Okay. So yeah, participants are good. I'll start the quiz now. Whether still joining. Okay, I'm starting the quiz. So the first question is just warm up to get you going with the. right now. पहला क्वेश्चन मैं कोई गलत कर सकता है, कुछ so easy. I'm very disappointed with my last Sakshi made it Prerna is first ball, Sakshi dropped down to second. Okay. The women empowerment सारे top में अभी लड़के चल रहे हैं. Okay, there is an Aditya. So I your नाम Aditya. Smriti is on the street. Prerna is on the street. Okay. Right. Smriti is on a streak. Right in a row. Okay. There's a 60% chance all the participants. That's really good. Okay, one of my classmates right here in the top three other participants. He's on the street. So let's go. Okay. There are still people who are doing it. Only 1 minute left. Leaderboard is looking really good. Pranav is on the top, Kenya on second, Athar Patil on third. Smriti has dropped down to 3. Athar Patil is on top right now. Kenya on top. Okay, time is coming to an end. जिन्होंने खत्म नहीं किया है, जल्दी से खत्म कर दो. Okay, so time has ended. And the game is now stopped. So the leaderboard, the first. Okay, Athar Patil is on top, Pranav SK on second, and Prerna on third. Really good, guys. So yeah, just drop us a message on Instagram. You will get our Instagram. It's CODECHEF KLSGIT, and just drop us our name, and we'll be tagging you after this session. So yeah, really nice. So okay, most of them have not completed the quiz, I think. But yes, really good score. And the break is over. It is time to call upon our second. Yes, our second next talk will be by Sneha. And Sneha is the tech lead here at CodeChef, and she's also been to IIT Delhi as a project trainee under ML, and she's been one of the mentor for my hackathon projects. That was Clash of Codes, and we have actually got the consolation prize for that. So thank you very much, Didi. And we'll just ask you, आप क्या पढ़ाने वाले हो हमें
Okay,
आज?
so the previous session was on basics of ML. So now I'm moving forward to algorithms. So this is the next part of machine learning after the basics. So this is how you actually learn about the models. कि बहुत सारे models हैं and there are a lot of problems. So कि कौन सा model किस problem पे use कर सकते हो, you learn that here. Yeah. Okay.
Okay, so I will give you the stage, and I'll be saying you bye bye. So go on with
Thank
the
you.
talk.
Is the PPT visible? All right. So hello everyone. I'm Sneha Dabadi, and I'll be carrying on with the algorithms part. So now this is a journey through decision journeys through trees, forests, and neural networks. Okay, so here, so well, uh, as funny as it is true. So machine learning is basically algorithms plus mathematics, right? So this is basically the theoretical version of what machine learning actually is, right? So this is excluding what it costs computationally. Like computationally, you will need some other resources. Like if you're training a computer vision model or some deep learning models, you'll need GPU or heavy power. So that is again the computational part that's different, but this is theoretically what machine learning actually is. See here you can see the penguin that's math is looking too short, but actually the math is pretty vast. It's not this small, so don't underestimate the math here. So, yeah, and don't worry, I'll not be boring you guys with math, but I'll give you an intuition of what algorithms or the machine learning models actually do, right? So, let's go forward. Okay. So, what are algorithms? You know what algorithms are, right? If you are like, okay, if you are in first year, you might not know, but algorithm is basically steps of instructions or a flow chart you can say based on how something should work. There are instructions given. Like suppose you're making Maggie and you know there are or anything basically packed has written in steps behind it. So it's just instructions of how what should go on. So here in this example, you can see on your left side there is a scattered group of fruits, right? So this is your data if you consider. So there are uh, three 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 types of fruits that you can see here actually. Like as a human you can classify it naturally that this is a grape and there's orange and this is an apple. It looks like a tomato but it's an apple apparently. So it is kind of scattered here. It's not specific. It is not classified. That is what your algorithm is supposed to do now, right? So here the machine cannot really understand what is that. So now you this is now fed to your system to your machine learning model, and then you can see on the right side that it has classified it as orange, apple and grape. So in the algorithm there are set of instructions or the set of features you can say, like there is the color, the shape, and color, the shape, and if you want it to be even more advanced you can add it like what taste it has, and then again classify it based on taste like sweet, sour, anything you might do. So this is an example to get started with, right? So let's go to the next slide. So here you have types of machine learning algorithm. So in the previous session, our Sarvesh explained you guys there is supervised learning and unsupervised learning. So here, even in the algorithms, you have supervised learning algorithms or supervised models and unsupervised models. Supervised are, they have labels. They have labels and they have already they have the classes written. Let's say you are using an Excel sheet. So there's already some values, let's say some digits given on your X side, and there are some words or some class already assigned to it. So if there is some new data point that it can go to somewhere, that it belongs to one of the classes. So that is one of the things that happens in supervised learning. And in unsupervised learning there are no labels. So the model learns everything by itself using the data points. So in supervised learning you have linear regression and logistic regression. Linear regression you guys have learned in the previous session, and there is KNN, there's K, that is the K nearest neighbors, and there's SVM, that is support vector machines, and there is naive Bayes, there is decision tree, random forest, and gradient boosting. So these are these are the supervised learning models or supervised learning algorithms that are applied to a lot of other applications, specific applications. So each of them perform the best in one of the applications. One model might work really well on a particular data set or a particular application, and the other might not. Some might be a bit more what you can say computationally consuming algorithms, so that might not really work. Some might need GPU power. So it's not that you can use one algorithm for everything. So this is something that I'll be telling you at the end of the session, that how you can choose which algorithm or which model you can use for which problem. So in unsupervised, there is k-means clustering and dimensionality reductions. These are a bit you can see a bit high level. That's not the scope of this session. So here I'll be covering supervised learning models, some of the supervised learning models. Okay, so moving forward, okay, so there are again classification algorithms here. So I'll be dealing with classification algorithms. So here you can see that it's being like an party organizer who exactly know where to put each guest based on their vibe. Suppose you're hosting a party at your place and you've invited all of your friends. So hypothetically assume you have 100 friends. So all of them are like, and apparently all of them are coming to the party. And not everybody comes early, right? So everybody is just like slowly coming in, and apparently at some point your house is full, all of 100 members are there. And all the 100 members are here. And initially nobody kind of goes and forms a group, right? So everybody is just there greeting everyone, talking, and just settling down, right? And then after some time people start forming groups. So let's say there's a group that's interested in music, there's one group that is into dance, there is one group that is like existentially frustrated, and there's just philosophical just sitting there. So you go there, you explore, let's say there's a one new person who's like kind of outside the group and just comes and just sees all this happening. You just first understand the lay of what's happening there. And then let's say he's into music, he sees there's someone guy singing or playing a guitar, he just goes and joins there. So he has found his class. So you in your party, let's say you have created some classes like music, existentialism, philosophy, and there's some band dancing. So you just go and join that, so you kind of know where you go, right? So this is like you also have an algorithm in your mind thinking ki, oh, I like this is something that's happening there and I might fit there, and you go there and you join that. So this is where a classification has happened in real life, right? So next, going so here's our first machine learning model, classification model. It is KNN, K nearest neighbors. So K nearest neighbors is basically an algorithm that has been the basis of this is distance or proximity. You will classify a point to a to a set where it is closest to. I'll be sure again, but this is the easiest algorithm, and it's also called a lazy algorithm for a reason uh, that you will see in some time. Okay, so here coming to this example here, just a minute. Okay, so uh, here there is just see this example here. So there is the first image here is the initial data, if you can see. So there are classes A and B. These are already given here in your data set. Let's say there is an Excel sheet. It is already classified into A and B, and here you have plotted a graph. Okay, so here you can see there are like the first image, there are like stars and there are triangles here, and बीच में there is a question mark. That's a new point, एक नया entry हुआ है इस data set में, and you are supposed to classify where it belongs. Does it belong to class A or class B? The पूरे classification problem है ना, there is just one point is trying to figure out where it belongs. So that's the whole point of classification कि कहाँ belong करता है ये, right? So there is this new point. The question mark is a new point. It is waiting to get classified into either class A or class B. So if you see here in the second image where the question mark is like directed to the other points. Okay, so यहाँ पे you just like you're calculating the distance कि कहाँ it is closest to the star or it's closest to the triangle. Okay, so you calculate the distance. The formula of distance will be discussed now. And then the last image here, the finding the neighbors and voting. So here in the k nearest neighbors, here's the point of k that comes, right? So k, you can consider it as a radius, let's say. So k is suppose 3. So 3 distance ka, you take a radius and there's a circle here. You make a circle. This is your neighborhood. The whatever comes in the area of that circle is its neighborhood. The question mark new point ka neighborhood. So now you see that as per this data, you can see there are 2 triangles and 1 star. Right. So this means that the question mark belongs to class B, because it is based on the majority voting or majority points that come in this class. So also finding the value of k is again a skill that you'll be learning. That is pure mathematics again. So this is the basic idea of what KNN is. This is also a main point in K means clustering that I have mentioned in the second slide. That is, it is a part of unsupervised learning, but the basics of it is again distance or proximity. Okay, I hope you guys have understood this example. Now moving forward, here you can see if I cannot actually zoom this image, but I'll give you an idea, right? So in the above image, I can see this blue and yellow color. So the blue color has small boxes and the yellow is a triangle. Okay, so this is what I'll give you. This is a very important tip that you're going to use when you're doing building machine learning model or working on any machine learning project. The main thing is data. So you'll be having a lot of data. I'm not speaking 100, 500. There will be like thousands, 10,000 million data points. Okay, and there you cannot simply sit looking at the figures, the digits on an Excel sheet, or like just looking at the raw data. You'll not be able to figure out anything. So the first thing that you're supposed to do is, after data cleaning, you're supposed to visualize the data. Like, as you can see here, it has certain patterns. So this pattern is called the U intersection pattern. You can see it's like a U shape. So this is really important to do data visualization, so that you can naturally classify even without using an algorithm. But if it is very simple, you can see. So I don't know if you can see it, but there are like some blue squares inside the yellow section. So here, as in the very first image on the left side, if you can see, you've taken the k value as 1. So the triangles are really close to each other. So that is why they have formed a class. If they're really close, it forms a class that it belongs to triangle polka. But here there is one square that's again close to another square that kind of has formed its own class there in the yellow section. So as you can see in the later images, the value of k has been increased. Okay, so the value of k has been increased, and you can see a more clearer classification till the last image. So even though there are more there are more triangles there, and there are squares here, it really doesn't, it is not that significant at a higher scale. Just think, if you're using thousands, 5,000 of data points, this much of classification error would not make too much difference. Okay, so yeah, this was the example that explains how the value of k um, works. Okay. Okay, so now coming to the distance here. So the value of k, I said, no, so it is based on proximity. So here are the formulas that you use to calculate the formula of how close the two data points are. Okay, so first one is Euclidean distance. It's simple math. It's a sum of square of this differences and the square root. Right. So this is Euclidean distance, and then there is Manhattan distance. Manhattan distance is very simple. It's just the difference between x and y coordinate points. You got that. So you can use either of the distance formula. Anyways, if you can see on the overall point that it is just a difference, just to see how close two data points are. Okay. So going to the next slide. So what we learned in KNN is KNN is a lazy learner. Okay, so it does not really train. As I told you, this is the first stepping stone, or the first point that you learn in algorithms. That it's really simple. Yeah, you're just calculating distance between 2 points and see if it is close. It's just like how you form groups. You're like close, you like it, and you get grouped there, right? So it does not really train on data set. They just memorizes the data and stores एक iteration हुआ where the k value was 1, and then there is second iteration happens. It goes on storing it, and suppose your data set is really huge and there are like millions of points, it just goes on storing it so much. It is computationally very expensive. You cannot simply use this algorithm on any data set. Like, you can't use it on vision data sets or anything. So it's very simple, like calculating classifying if a tumor is like benign or malignant, as discussed in the previous session, or if a person is diabetic or non-diabetic. This kind of simple examples you can use. You can not train again. You can use KNN algorithm for. And here, as I said, the majority voting, the number of triangles or more than number of stars. So hence it went to the triangles section, class B, right? The distance metric. So this is basically based on the distance formula. Okay. So yeah, here's the meme for KNN algorithm is that the students who struggle with math, this is based on a thing where people usually think that people who are good at math have a certain kind of an attitude and they form their own group, aren't really too open, and so the people who are not good at math have to make their own group, so making closer friends than ever based on the data points. Okay. Moving forward, we have decision trees. So you can call decision trees as the Sherlock Holmes of algorithms, reducing decisions effortlessly. This is the most, you can say, logical algorithm. If you see, this is something. It's if you're under the hood. If you see, it's simply if else loops everywhere, right? The decision trees are. It looks really cool, like you're deducing something, if it is this it is linked to something and all, but it is just it's just again if else loop and the trees branching out. You can just explain it now. And so what can you use it for? This can be used for a lot of things. If you see this, like the question one, this is like to just for anything. It's not necessarily like you have to use it for a really complex problem or anything. So do you feel like being comfortable today? Or if yes, then do you have a hoodie? Yes, then wear a hoodie and sweatpants. If no, then wear pajamas and call it a day. No, if you're not feeling like being comfortable today, then you can. Do you feel fancy? Then wear a fancy dress or a suit, or go with jeans and a t-shirt. So you can use decision trees for such simple things to something like this. So this is the main structure of the tree. There is a root node, there is a decision node, and there are leaf nodes. So this is, you can see a subtree on your right side. This is something that you can use to calculate, to understand the risks to prevent a heart attack. So if your age is like between 18 to 30, then you have low risk. And if you're a smoker, yes, no, there's a low risk, and high risk if you're a smoker, no, low. And based on age and weight. So these are some parameters that your model considers. So this is again, there's math behind it again. This is the easy way to understand. This is like the simplest way to understand decision tree, that there are nodes. There is s no, if yes then no. Again, as I said, there are if else loops everywhere. Okay, so here is the math for decision tree. There is splitting criteria. So as you saw here, it is split at some point, right? So it's not every time that you get such a simple data set, if yes then no. So there are a lot of, like, if we are given a lot of digits, x, y coordinates, so then you have to use something called as Gini index. So Gini index is the formula for Gini index is here. So this is a splitting criteria. So if the value of Gini index is less, that point you consider for the next splitting, if it is yes or no. So here it is 1 minus sigma pi square. Pi is the probability of the data set, pi square. So just this is purely a simple equation. And this entropy. Entropy is again similar to what you've studied in physics. It's just the mathematical approach here, mathematical statistical approach here. You can use Gini index, you can use entropy, these formulas to get certain value that can be further used for classification. Okay, or the splitting criteria. Okay, going. So these are the formulas. This will be shared. You guys can see it later. And yeah, so this is something you guys can like try today. Instead of guessing what's for dinner, use a decision tree like kal ye banata, kal ye banata. These are the ingredients available today. Then you can guess what you'll be having for dinner tonight. Okay, so right, moving forward. Random forest. So read the lines. Let's see what's here. Okay, so I think this must have given an idea of what random forest might mean. That is, this is just an ensemble of trees. There's a group of trees that are used for more classification or one set of classification. So you can see there's a data set, and these are features. There are a lot of features. This is particularly for a more diverse data set, you can say. So for every feature, there is a decision tree made. So there's a decision tree made, and after decision tree, naturally there is a class that comes out. So there are, for in this example, you can see there are 4 features, and चारों features के लिए there are decision trees made, and hence you get 4 different classes. So इसके बाद, if you want to further classify it into one more class, or maybe multiple classes again, you have to consider the majority voting ki, if this class has more number of parameters, or this class D or class B has, and then you decide a final class. So this is how random random forest works. It's just a lot of trees. It's like a team player thing that you get, yeah, that happens here. Okay. Going forward, so the focus point here is, again, it's very similar to what trees look like. It has a root node and there are splits, and again the same criteria used, same mathematics is used. There's information gain, there is Gini impurity, and there is recursive splitting. That is, ये बार हो रहा है. Decision tree में एक ही बार होता था. This is like happening multiple times, and you're getting multiple classes, and then you're merging it to one. All right. So next, here at this point, I can highly relate to Barack Obama. Well, I don't know who this person here is, but the next topic is indeed neural networks. It is not complex, I can say. It's not like highly complex. Of course, at higher levels, it is complex. But for now, I'll try to explain it in a simple way as possible. Okay, the star of the show is neural networks. It's basically a brain, but fewer existential crises. Ouch. Next. So this is the structure of neural networks. So we have this is the basic structure of neural networks. There is input layer, there is hidden layer 1, hidden layer 2, and there is finally one output layer. So it depends a lot based on how many input characters you have and how many output characters you want. There are multiple features, and you suppose there is one thing that's coming out, like if it is a cat or a dog, there is just one output. It can either be cat or it can be dog. Right. So there can be multiple hidden layers based on the complexity of it. So there are neural networks is like highly modifiable. You can add a lot of things, you can remove a lot of things. So this is the basic structure of what a neural network looks like. Yeah. So this is a neuron, or it's called as a perceptron. It's a single part of a neuron. So this one part, you can say. Okay, so here x1, x2, and xm, these are all inputs, and bias or summation, it is a function. It is a function that I'll explain the mathematics of it later. This is a function, and then there is activation function that just shows if how relevant something is or how irrelevant something is. It's all numerical values, and then you can get an output. So bias is, again, the summation, and the activation functions are pure mathematical functions that help you to further classify things and get an output. Okay, moving forward, so structure of a neuron, again, as I said, there is input. It can be anything. It could be pixel values, it can be numbers, it can be features like ears, nose, mouth, or anything. Then there are weights. Weights are assigned based on features, how important a certain feature is. Then it will have more weightage. Okay, because the data is pretty noisy, you cannot consider everything, so certain weight is assigned to certain features. Okay, then there is transfer function. Function is the one that's the bias or the summation function. So it contains multiple input to give one input. It's again mathematical function that goes on internally. And then there is activation function. It includes non-linearity. It's like it's not simply going in a straight line that you can predict it easily. That is why we have neural networks. Otherwise, we would have used linear regression. Okay, and there are multiple layers that are used. So it depends on your use case. How many how many layers you would need or how complex your model is. Okay, so here is an example, a typical example that we use for neural networks, that is handwritten digit classification. So here is an example, handwritten digit classification. It's actually a big project. If you can get the dataset, it's called MNIST dataset. You can find it very easily. So it is a huge dataset. So here you can see two. Two is one of the many images written as two with the hand in the handwriting. So here you have the input neurons are 784. You might wonder why 784, because the image taken here, or the image in the MNIST data set, is 28 into 28. That's the pixel value. So 28 into 28 is 784. So every pixel's value, you consider every pixel's value. And there are these many neurons. These are 16 in the hidden layers. And the output layers are 9, obviously. So the number belongs to one of the 9 numbers. So here, if you go, right. So every number has its own side. So let's say there are certain edges that is in one number and it's not in other number. 9 has these specific parts. There is a circle and there's one straight line. So that is what makes it 9. Right, and the machine has to, in order for the machine to understand this, it has to break it down in a way that it can actually classify it, figure out the differences what are there in the numbers ranging from 0 to 9. Okay, so 8 has like a 0 and a 0, niche upar ek 0 and niche ek 0, and then there is 4, and there could be a lot of numbers resembling 4, because there are these many parts, and the straight line and O is kind of a common digit in everything. So that is see, if you can 0 to 9 mein there are so many differences, so many variations. You cannot that is why we have so many layers. We'll have a lot of layers in order to, and each layer will have a certain feature that it can identify. So this first hidden layer, you can see it may be there for detecting edges. So it is like if one of these numbers has an edge, let's say, then that will be captured by this particular hidden layer. So there can be multiple layers like this. Okay, that will again further classify and give light up one of the lights from 0 to 9. Okay, going forward, well, if you might wonder how these works, and then the answer is, well, math. So here is the mathematics, that is as I explained in the structure of neuron, there is a weighted sum. So it's a linear transformation. Basically it comes to linear regression only. So Z function is weight into the inputs plus the bias, as it was explained in the first session. And then there is activation function. Activation function is basically one of these neurons just light up if the value ranges from 0 to 255. 255 is white and 0 is black, right? So based on the value of activation function, you can the one of the neurons light up, and that shows its significance. Let's say one of the edges is captured, so that edge belongs to a certain number, so that then redirects it to one of these neurons, and that neuron lights up. Okay, so again there is so from going from hidden layer to the output layer, there's another mathematical function called as the softmax. So यहाँ पे there's again, this is a mathematical function, the z that you calculated in the previous slide, the weighted sum is used here, and you get the value, and that is again it lights up another neuron. Okay, and then you calculate the loss function. Excuse me. You calculate the cost function, or the loss function is basically the loss. See how you can improve it. And there is back propagation. So we're doing machine learning. So the neural network has to learn. This is something that happens with your brain as well. It's not like you see something and you remember it in the first instant itself. So you have to go through that again and again. So this is the back propagation process. Excuse me, sorry, just give me a minute. Okay, I'm back. So this is the gradient descent, gradient calculation. So this is something that you saw in the previous session as well. here we use the loss function here. This is one of the things. And there is the activation function and the weight function. So all these are partially differentiated in order to get a value. It is very similar to the gradient descent that you learned. And after this part, you have weight update. You after all this calculation and weight as it is learning, you update the stuff that's happening. You update the weights and you realize what how much importance is given to one of the things, so that the model learns all that and then continues the whole process, and it depends on how many number of iterations you give it to it. And then on the basis of that, the machine learns and tries to give the right output. So here is one of the examples where is input is the image of George Washington. So it calculates, first identifies the dark and the light pixels, and then it identifies edges, and then the combination of edges. So this layer performs on identifying edges, another layer performs on a combination of edges, and then the important one classifies it based on the features. And this is the output. The output might have a lot of classes defined again, but here, as per the mathematics that goes on here and the features, the output is George. Okay, so this is with an example of how neural network works. Okay, now now you guys have learned so many models, so many algorithms, so you might be in confusion that what will I use for which example. So here we go to the slide. You guys can see here, this is a very standard cheat sheet that scikit-learn gives. That is, you start first. I am not able to zoom here, but if you can, when you get the PPT, you can definitely zoom it and see. So if your data set is like has more than 50 samples, so that is actually something significant. You cannot do machine learning or data analysis with less than 50 samples. That's really insignificant. It's not really worth doing it. So these are basically the classes, that is regression, dimensionality reduction, clustering, and classification, as I said. So if you want to, that is what you do. So if you're predicting a category, then you go to classification. And again, in the classification, if the samples are less than so or so numbers, there are other methods that are beyond the scope of this. But there are again more there are more models under classification itself. तो वहाँ पे you can just based on the data set, you can consider that particular model or algorithm. And if you want to do regression, or if you want to find a quantity of something, a numeric value, then you go to regression. Okay, so if you're looking for if there's huge data, dimensionality reduction is basically there is certain data that's not it's not proper for your application, then you do dimensionality reduction. And that is also again based on the size of your data set and the quality of your data set. And clustering is basically, as I said, it's again uses k-means clustering method in order to cluster one cluster. The cluster is different to classification, but it's again clustering it into certain groups. Sorry. So this is the cheat sheet that you guys can go through in detail. Moving forward, well, I hope you guys are looking like baby Yodas right now. And to see that all these predictions that are happening are basically based on classification models. Okay, so this was me explaining algorithms, and I hope you guys have understood it and will be able to implement it further. And I think it's time to call Aditya back.
Yeah, so thank you very much for this session. Sneha, it was
Welcome.
really a great session. And yes, कल मैं chat GPT बनाऊंगा and
Good luck with that.
thank you very much. So yeah, rest Sneha, बहुत अच्छा session था. And
Thank you.
we'll be saying you bye bye.
Bye
And
bye. Yep.
Sarvesh, I will be calling upon Sarvesh, the president of our club, to take the session further and introduce our guest.
Thank you, Aditya. Thanks for your time. Thanks for the introduction and your efforts. Cool. And guys, here we are, the main part of the session, how to use this knowledge base, which you have gained right now, and apply for internships in research, or internships in any company which is working on ML, machine learning, basically. The companies like Deloitte, companies like Salesforce, and companies like Accenture basically look for mainly focus on students who have done their projects mainly on machine learning. So here is our guest for today. Currently, hi Sukanya, how are you? Our guest for today. Let me introduce you guys to our guest, Sukanya.
Hello.
Hello Sukanya. Hi, how are you?
Hi, hi.
And how was the day? Was it like too hectic?
No, no, I was fine. Thank you so much for having me here.
Cool. I'll just give a small introduction of yours to
Yeah,
our
sure.
audience. Guys, Sukanya is studying in SRM right now, SRM Chennai, and she is in her third year right now, and she has done 1 year of research and one month of research internship under the guidance of an IIT professor who is working on his PhD. So the journey that she wants to share with us is very good, inspiring for you guys, you folks, because she had literally DM'd every professor from IIT to take her as an intern, assistant researcher. And that's all from here. Sukanya, the stage is yours.
Okay, I'll be sharing my presentation.
Sure.
Is it visible? Can you confirm if it's... Okay, so hello everybody. I'm Sukanya. Again, I'd like to thank Sarvesh and Sneha for having me here as a guest. So today, I'll be speaking about how to basically get an internship at a good IIT, and how to build your profile in order to get one. So a little about me. So again, hello, I'm Sukanya. I'm currently pursuing my BTech in SRM University. I'm in my third year and I am studying computer science engineering. I'm basically a machine learning enthusiast, and my major areas of interest are computer vision and deep learning. And like Sarvesh had mentioned, I was selected for the summer research fellowship program. Um, 2024 at IIT Delhi, and I was fortunate enough to get an opportunity to intern there for 1.5 months under Professor Aditeshwar Seth. Moving on, talking about understanding the entire process, the eligibility, and in general things to know before applying to IITs. So basically, there are two types of internships. There are two ways of getting internships. One is applying for the official, internship programs that happen on a yearly basis in most of the top IITs. So that happens through the portal. And second would be emailing professors. So who can apply? Basically, all engineering students in their second, third, and final year of their undergraduate studies can apply. But a few of the internship programs, for example, the summer fellowship program in IIT Madras, a few of these have a restriction that only third year and final year students can apply. So basically, before you go ahead and apply, just have a look at the eligibility criteria. But most of these do allow second, third, and final year students. And then coming to when to apply, the timeline. So for cold mailing, you can ideally just cold mail the professors you want to work with anytime throughout the year. Mostly professors like to take interns in either during the summer or the winter. So basically 1 or 2 months before your summer break or winter break would be good. But a lot of professors take interns even during normal working semesters. So anytime, according to your preference, according to your liking, you can keep trying to mail different professors that have same interests as your domain. And as to for the official internship opportunities, the programs that IITs have, so all of them are only open in summer. So the applications for them start in February to March. Some also happen in April. So February to April is where the application period is. Moving on. Yeah, so the type of programs, like I mentioned, one is the official program and one are the unofficial positions that are through the cold mailing. How to apply is the same. You For the official programs, you'll have to apply via the IIT website. So each IIT that hosts an internship program has a different separate website that is dedicated to it, that gets active around February for the applications. And for the unofficial programs, again, sending emails to your professors that you want to work with. Moving on, so how to get selected, how to build a good profile, work on good projects in order to ensure that you do get selected for an internship like this. So the selection criteria is majorly on your work, whether or not that aligns with the professor's research interests, because professors would like to take students that have worked on similar projects, papers, etc. Because ultimately the goal of an internship in IIT is to publish a paper or to do a project that will contribute to a publication. So basically, the most important thing is your projects, is how the projects that you've done, is it in the domain of the professor that you want to work with. And then just a suggestion would be, to be consistent with your work, with your projects, and do proper research before mailing your professor or applying on the website. So now moving on to the key elements. The first would obviously be a CV. CV is required for applying, and even when you cold mail your professors, you have to attach your CV. That's a must. So for your resume, usually you have to keep it concise. A lot of colorful, large size text resumes are not good. The formats which are very minimalist, with small texts and just concise information, are ideal. And only focus on what domain you would like to apply for, when it comes to mentioning stuff in your CV. Usually a lot of students think that, if they mention a lot of different things, for example, ML and full stack and a lot of other like different type of things, that would be good, but that is actually not the case, because you should only mention things that are that fall in your domain, and not a lot of things, because ultimately your professors only the professor that is going to take you in is only going to look at if you have done projects in that relevant area and not other things. So it's best to mention details only from one certain domain, which is machine learning, and also not add information that you cannot justify, because a lot of students add a lot of projects that they have not done, or they cannot explain. So that, again, if you have an interview round or when you meet your professor, if they realize that you do not actually know all of the information that you claim to know, it's going to be a huge disadvantage. So that is that. And coming to projects, so project is also just as important as CV, because that is the major basis of selection. So you have to showcase projects that again align with your professor's work. And it's a very good practice to upload your projects on GitHub, document them well, and just commit on a regular basis, because professors do always check GitHub, LinkedIn, of whoever applies. So it's a good practice. A few examples of projects that I had worked on. So basically, projects can be beginner, intermediate, and advanced. So a few beginner projects would be just general classification, detection, object detection, binary classification, multi-class classification, etc. For example, fracture detect. I had this project which I had done in my first year, which was which was a computer vision project from X-ray images, which was detecting fracture, classifying whether or not an X-ray image had a fracture, and also using a YOLO V8, or using the YOLO V8 model, uh, detecting the area of the fracture. So that would be a basic project. Also, any sort of a basic classification, transfer learning, using pre-trained models. These would be basic to intermediate projects. Advanced projects can be multimodal learning. So multimodal learning is when you basically train two or more different types of data together in one model, and you fuse their outputs. So I had done this project on multimodal learning for Alzheimer's detection, which was using both lab numerical data and the MRI images. So that is one good project, a multimodal project. Also, any amount of segmentation, instance and semantic segmentation. I had done another project which was for boundary refinement of medical of tumor detection in MRI images. My major domain is medical computer vision and medical applications. So it was a hybrid model of the pre-trained detectron 2 and a CRF architecture for the boundary refinement of tumor detection. This is another good advanced project. So similarly, whatever your area interests are, you can put in time, research, and do good projects and showcase them, which professors, that's definitely one thing professors look at before selecting interns. Moving on, research experience. So research experience is actually also very important. So in order to a lot of students in college do not have a lot of exposure on research experiences, on how to start on writing a paper. But I think the most important step in that would be talking to your faculty, any faculty that has the same works on the same domain as you do, as you want to. So you can go talk to them and you can ask them if they have any ongoing paperwork going on, or if you could write a paper for them, and just spend a few months and write a paper and try to get it published. So this will not only help in your IIT application process, but also for future if you want to do masters, etc. If you want to just be in research, in engage in any sort of research, this would be a great thing. So another is SOP, which is your statement of purpose. So for all of the online official IT internships that you have to apply for, you do have to write a statement of purpose, which is between 100 to 250 words. I had to write one for my IIT Delhi application as well. So in that, you're just supposed to mention about, briefly introduce yourself, what you're studying, what your how your academic background is, basically your CGPA, if you have any distinctions, scholarships, etc. And then about what your interest domain is. So you'll have to select a professor before applying. So there'll be a list of professors provided on the IIT website, and you'll have to select a professor that you would like to apply under. So before you write your SOP, it is suggested that you go to that professor's page, look at their papers, look at what type of projects they work on, what type of papers they're writing. So based on that, you write your SOP. So based on that, you can your SOP, you can mention you can mention key skills that are required for this, like for this domain. For example, if they're working on let's say a medical imaging, computer vision medical imaging applications, then you can say that, okay, I have good experience with computer vision, object detection, segmentation, etc., and I have worked on these XYZ projects, which are very similar to whatever they work on. So this way the professor knows that you're interested, and also they would find you resourceful, and they would feel that your skills are relevant, and they would want to take you in. So in your SOP, research about your professor before writing an SOP, and then mention your projects. If you have any research papers, mention them, and also mention why you want to work under the professor, that you're determined, etc. That you're very interested in how this internship would help you, how what you would gain, etc. So writing a good SOP is like key to getting selected for an internship, especially the official ones that are through the website. Moving on. Okay, so building a strong portfolio and image is just as important, because when you apply, professors, whoever is selecting you, they will always check your GitHub and LinkedIn. So having a good profile in both of these places is very important. So for GitHub, consistently try to build projects, even if you think they're very basic. It's still, it's over time you develop over them. Just keep committing. Provide proper documentation for them, for each project, even if it's pretty simple. Make a readme, add your results, add what the project is about, add a few output images, etc. So this indicates that you write good code, and that you are, that it's just a good thing. Even for placements, for IIT internships, for anything, making uploading your code on GitHub and documenting it well in form of the readme file is an amazing practice to do. Another thing would be engaging on LinkedIn, sending out a lot of connection requests to people in your college, professors, to people from other colleges, and connecting with different people, so you could potentially work on future projects, and also just build your networks, for internship opportunities, etc. Having a good LinkedIn with all of your updates, all of your certifications, all of your experiences, posts about you winning hackathons, etc. So this This is a very big plus point. Another, for networking, you can attend hackathons, workshops, webinars like this one. You can connect with different people with similar interests, with a similar mindset. And always try to, like, usually when we have our faculties come to class, we don't look beyond that course, but connecting with your faculty and trying to just let them know that you're interested in doing a project. So whenever they have an opportunity for any project or an internship, they would come to you, because usually students don't do that. They just want to listen to class and leave. But you should reach out to your professors always, because faculties always have a lot of opportunities, even if it's under them or external opportunities. So yeah, stay connected with your faculties, with a lot of students with similar interests. That would be for that would be enough for building a good network and for networking. Yep. And this how to cold mail professors. So apart from the official website application, cold mailing professors is one way you can get a lot of this thing opportunities. I had cold mail a lot of professors from different IITs, and I had gotten a response from a lot of them. So but the thing is, you'll have to write a lot of cold mails. The thing is, usually people write like mail 5 to 6 different professors, and they don't get a response, and they think that it's very hard to get a response. But you have to like mail a lot of professors. I had mailed a lot of professors, and like probably I'd mailed maybe 50 to 100 professors, and I had gotten 5 responses. So you will have to mail a lot of professors. Usually the professors from IIT Bombay, IIT Delhi, the higher Kharagpur, these don't usually respond. It's very rare to get a response from them. And also they usually want a 6-month in-person internship, which is hard for anybody that is not in their final year. So yeah, but the lower IITs, like for example IIT Bhubaneswar, BHU, all of these professors do tend to reply if you are a good fit for them. So yeah, so there are 2 steps to cold mailing professors. First would obviously be uh, finding the professors you would like to work under. So every IIT has their website for faculties. So you can go under the CS department, and then you can just search for machine learning. There are all the professors listed according to their position and their area of interest. So you can always go search them, and then always their mail ID is linked in their website. So you can make a list of the professors you would like to work under. So that is obviously the first step for cold mailing, and the second would be crafting a mail, which is very important. So make sure that your mail isn't very long, because professors usually receive a lot of mails. There are so many colleges like yours and mine. There's so many students out there that would like to receive an internship. So professors just don't have the time. You have to make sure your mail is short, around 100 to 300 words, I think would be ideal. And is straight to the point. You don't have to yap a lot in your email. And then so you can start out with a brief introduction, a very brief introduction about who you are. You can just say, I'm pursuing this from this college, I'm in my 3rd year. And you can mention your CGPA if you'd like. You can mention your CGPA and other academic, if you have any like academic this thing, distinction, scholarship, awards, etc., you can mention that. And then you can talk about your projects, your area of interests, and how you can contribute to that professor's work. So that would be, I think, the most important part, is what your which area you're working in, what projects you worked on, and how you can significantly help the professor. And then also express genuine interest. You should make the mail sound like you are determined or genuinely interested, and that you would give your 100% if they would take you in. So a lot of professors, even if you don't have enough experience, even if you're really determined, and even if the professor sees that you have a potential to grow and to do good work, they would still take you in. So that is another very important aspect. Even if you do not have, even if you think that you're not confident with the experience you have, with the projects you have, still try your luck. Show that you're genuinely interested. Show that you have this one very strong will to work under them, and it really might work. Yeah, and then do attach your resume. That is very important, because some professors don't even actually go through the content of your this thing of your mail. They just directly open your resume to see, because that's pretty much all that they need. So make a good resume, attach it in the mail, and you may also attach GitHub links to your projects, or any, if you have any functional websites, etc. You can just attach links to your to the a mail as well for them to see. Yeah, that's pretty much it for cold mailing professors. Moving on. Yeah, Q&A. If any of you guys have any questions that you would like to ask, you may drop it in the chat box of the Gmeet, and I'll answer them. I think there's a delay in streaming, so I'll have to wait for a while.
So I'm back,
Hi,
Sukanya,
Sarvesh.
and that was really a great one. I wanted my folks, my college mates, to know how can they, being from a third tier college, apply for research internships in IITs and NITs. I really myself want to see my juniors doing great, man.
Hmm.
Hoping they'll do. Yep. So we'll be getting the chat in a while. Guys, you can chat in WhatsApp till now, for now, time being, and later we'll be turning on the Google Meet ka chat. Okay, you guys can chat in the WhatsApp, please. If anyone has any doubts, I guess the session, well, like your explanation was too good that they don't have any doubts. I guess the Google Meet chat is there. I guess one of my co-hosts, Aditya Singh, has a doubt, and he'll be coming on live. He'll be joining us.
Hmm.
Aditya? Yep,
Yeah,
he's there.
hello Sukanya.
Hi, Aditya.
Yeah, so I had a doubt. As you said कि emails के reply तो आते नहीं, like बहुत कम ही आते हैं. So
Hmm.
does the domain of your email changes that? Because like अगर मेरा student account है या फिर मेरा IEEE का account है या फिर
Hmm.
I have an domain that is not @gmail.com, does that change anything?
So I don't really think so, because I had reached out my professors through my personal mail ID. But I think most students do mail with their professional SRM. I'm sorry, not SRM. Their professional college ID. So I think it doesn't really matter if you have a college ID. It's just they have the sort of verification confirmation key, yeah, you're a student, you're legit. But I mean, at the end of the day, it's obviously your basically the contents of your mail and your experience. It's really up to you if you would like to use your personal mail. The thing is, for my college, my domain mail ID does not have my name. It's like a number, which is a register number. So that's why I preferred my personal mail ID over the my college one. But it really depends on you, whatever you wish. I don't think it has a very big impact. Doesn't really matter.
Okay. Thank you very much, Sukanya.
Yeah.
Cool. Thanks, Aditya. So I'm getting some doubts from my folks. The thing is,
Hmm.
few people have got to know that ML is purely based on research.
Hmm.
So, मैं क्या बोल रहा था? ML is purely based on research. So, what are the basic projects that they can build on? Like starting project, like you might not be your Python is easy to learn, right?
Yep.
So they can start up with Python. They can do Python.
Hmm.
And what are the basic projects that they can build using which frameworks they should start with the exploration?
Okay, I think the first step to ML before even learning about the algorithms would be, like you mentioned, data exploration, which is using pandas, NumPy, Matplotlib, to build a strong base before you move on to TensorFlow or PyTorch, would be, being familiar with NumPy, pandas, and Matplotlib, analyzing the data, etc. Because that is the base, obviously. And then moving on to machine learning. Either people use PyTorch or TensorFlow. I personally use TensorFlow. Uh, so I mean, okay. Also about different machine learning algorithms, you can learn how to. The project building is not that hard for machine learning. The hard part is the math behind it, like Sneha had mentioned, the math and the logic behind it. So for projects, obviously, going through different basic classification or basic detection things. Like the basic project would be, like cat and dog classification that all of us go through before we start ML, or basic disease classification, or based on multiple tabular data predicting multi-class classification or detection, like that. And then if based on your interest, you could either do computer vision or NLP. So in computer vision, again, you could start off with basic image classification, multi-class classification, object detection, segmentation, etc. And for NLP, honestly, I don't have a lot of experience in NLP, but you can just start off with basic LSTM, BERT, like pre-trained models. So yeah,
Cool.
these would be a bunch of basic projects.
Cool. Cool. Thanks for putting light there.
Mhm.
Okay. Now again, one more doubt. I have been exploring ML since a year. The
Mhm.
main part where I've got a guidance from people from industry is to implement research papers.
Yep.
What
Yeah.
would you want to say on that?
So I think, like you said, ML is very like research oriented. So most people that do ML in colleges for writing research papers. And if you want to write a research paper, you should start off with implementing other research papers. Like, you can take basic papers that other authors have worked on, and you can try to implement their code. And while you read a lot of research papers and tried implementing, playing around with different codes, you get an idea of your own, you get an idea to write your own research paper. So yeah, but research also, ML is not totally research oriented as well. A lot of people, if you want to become a data scientist, I think ML is very important. That is one of my aspiration. So yeah, if you're doing, it's not that if you're doing ML you only are going to end up in research. You can also, there are a lot of other industry wala options like data science, analytics, etc.
Cool. Yep. And okay, how do you think? What would you say for someone who wants to implement a research paper? अभी ML के concepts खत्म हुआ है. How should he start implementing research paper? Where should he find, and how can he evaluate that the paper is good for me to implement? How
Okay,
can he
so
judge that part? Yeah.
I think most of the papers are pretty complex because obviously they're research papers. So if you if you're done with your basics, if you've done a lot of projects, you can just pick up like, if for example, if you're looking to implement a research paper, make sure that you're able to understand what the title says. Because if you want, if you're looking for research papers to implement and you don't even understand what the title says, because some of them are too complex, it takes time to understand, obviously. So if you just want to begin with implementing a research paper, make sure that you're fully able to comprehend what the title says, and then go ahead and read the content, what the authors have done in that paper. Some papers are pretty simple. They just implement a bunch of models like random forest, decision trees, etc. on their data. So see what data they've done, go download that data, because it's mostly open source data that's used. If it's not, then you can download similar data if you can find it, and then try to see what models they've run. If you don't know how to run them, you can see the code, you can see YouTube videos, you can use GitHub code. Also, you can use Chat GPT if you're stuck, if you have errors. So yeah, you just go ahead with that. See if your performance metrics like your accuracy, F1 precision, etc. matches theirs, if it's the same. And just so that you'll be able to totally understand the thinking behind the authors and what they've written. And also this will be helpful for writing yours, because when you do your project, when you have an intention to write a paper, then you'll be able to understand, like, how do you write the paper, where do you make tables, what type of diagrams you have to add, etc.
Cool.
Yeah.
Cool. I guess the questions are done. We'll give 3 more minutes. Not three. We'll wait for a while.
Okay.
Cool. Then, would you want to explain us one of your basic project? Very basic. 2 minute में जो हो जाए.
Basic. I have this project that I had done in my first year when I was a few months into learning. All of my projects were actually mostly computer, which is image based, computer vision based. So one of my projects were it was basically plant disease detection. So there were 6 different types of plants, and there were I think around 8 to 10 different type of diseases that were found in the plants. So they were like, there was a data set with a lot of images of different leaves, stems, etc. And I had used a pre-trained model. That was my first time I had used a pre-trained model. You can go ahead with making models on your own also using TensorFlow or PyTorch. But if you use pre-trained models, that's also very good. Like especially if you're going into research, using transfer learning is amazing. So I had used the pre-trained ResNet 50 model, and I had sort of detected diseases. It was a basic multi-class classification project. Yeah,
Cool.
that was one basic project.
Cool. Cool. Then I guess we are done for today. On behalf of Coach Chef Club, I really want to thank you for joining us.
Yeah,
Thanks
thank you.
for putting light on that
Mhm.
path. And yeah, thanks for sharing your journeys, Sukanya.
Okay,
Cool.
thank you.
Thanks for joining us. And yep, guys, we are done. We are done with our workshop. We surely thank our guest for today. And I would really like to thank our team, Coach Chef Club, and mainly our main hard workers for this event are Atharva Nayak, Aditya Singh, and Tanishq. A huge shout out for these people for putting their efforts into making this event happen and handling the complete back end and the front end part, front end, back end, backstage, and the front on stage part. Aditya was handling the front stage and Atharva was handling the backstage, while all the PPTs and the memes were taken by Tanishq. And thanks Tanishq for your humor, dude. Seriously, all the memes were crazy. And thanks Aditya and thanks Atharva. I guess these people are here. You guys can turn on your cameras, please. Yep, Tanishq is there, Aditya and Atharva. You guys can join us. Yep. Thank you guys, and it was a great event. Shout out for you guys. Shout out for your efforts. Tanishq. And thanks, Tanishq, for your humor, dude. Seriously. All the memes were crazy. I'll see you guys. We need to cut the meeting, okay?
Yeah,
Bye
yeah.
bye.
Thank
I
you
guess
very
these
much.
people are here. See you guys. You guys can turn on your cameras, please.
Yeah, thank you
Yep,
for
Tanishq
having
is there,
us.
Aditya and Atharva. You guys can join
Thank
us.
you everyone for joining the event
Yeah,
and making
thank you
it a
for
huge
having
success.
us, and
Yep.
it was fun.
Thank you guys, and it was a great event. Shout out for you guys. Shout out for your efforts. And thanks, Tanishq, for your humor, dude. Seriously. I'll see you guys. We need to cut the meeting, okay?
Yeah, yeah. Thank you very much.